Good morning, everyone. So, our topic for today in the period of midterm is the application of error to compass. So, our course outcome. So, at the end of the session, the students will be able to learn application of error to a compass. Then, our learning outcome is at the end of the session, the students shall be able to determine the use of application of an error to a compass. So, the application of error to a compass, the courses and bearings laid on the chart are true, but we steer courses and take bearings using a compass. The compass used in a small vessels is more commonly a magnetic compass, although some may be fitted with a gyro compass. It is suggested that this section be read in conjunction with learning outcome. So firstly, we will deal with the magnetic compass and the errors involved. Then the difference between direction as measured by the compass and the true direction as measured on the chart is termed compass error. Stated differently, it is the angular difference between the true north and compass north. It is named east or west to indicate the side of true north on which the compass north lies. So as you can see in the illustration, figure 2.14, this is the direction of compass error.
Good date for the continuation of the report. So here's my part. The compass error is the combination of two separate and distinct components, namely the variation and deviation. First is the variation. When influenced only by the Earth's magnetic field, a compass needle will point towards the Earth's north magnetic pole. This pole is located somewhere to the north of Canada and is slowly moving. Examination of a globe will show that from a position of the east coast of Australia, the compass will point in a direction the east true north. This magnetic north and the angle between it and true north is called variation. So in our case, variation is east. So variation, to find the value of variation for any position, simply consult the nearest compass rose on a marine chart. The variation will be given for a specified year together with the rate of the change, allowing calculation of variation for any subsequent year. See appendix of variation chart of the world. Example, chart AUS 823 gives the following information that compass rose to the south of island. Okay, so showing you the example. Next is the deviation. So in the unlikely event that a vessel is constructed entirely from non-magnetic materials and has no electronics, closed, and a compass, variation is the only error which will need to be accounted for. In all other cases, the vessel or its equipment will create magnetic fields of their own. Some of these will be built into the vessels on the ship. Furthermore, to illustrate the effect of the vessel's own magnetic field, imagine a vessel in which compass needle is attracted towards a stern. The vessel turns onto in easterly headings. The compass needle is deflected towards the stern. When the vessel heads west and compass needle is deflected to the east, there will be no deflection when the vessel heads south but increases in directive force. Another, this deviation of compass away from magnetic north is called deviation. As with variation is named east or west and the value will change according to the ship's heading. A deviation card is produced by the compass adjuster when the vessel is first commissioned and it intervals throughout its life.
Rules for applying variation and deviation. To avoid drawing diagrams every time variation and deviation are applied, a number of memory aids have been developed to clarify the rules of application. Television makes dull company reminds us to the true we must apply the variation to find magnetic, and to this we will apply deviation to arrive at compass or course or bearing. If we start with a compass bearing and wish to convert it to true, it can be used on the chart. The order of operation is reverse the CDMVT. Having decided to the correct order in which to apply variation and deviation, we need to know whether the correction should be added or subtracted. This may be decided using the word. So that's all for today's discussion. So next reporter will be our co-member. Thank you.
So for the cadet, this simply indicates that to get from compass to true, or the endpoints, we add east. So given that we add east, the deviation or variation, it follows that we must subtract west, deviation or variation. It also follows that we if we add east to get from compass through, we should add west when going from compass, from true to compass. Simply layout for applying these rules is shown in the next page. So uh, first, let me explain the compass error. So compass error, if we expect to take several bearings whilst steering the one steady course, it makes good sense to arrive at single correction, to apply to all those bearings, remembering that the variation remains effectively the same whilst operating in one area, and that deviation only changes when when change course. We can find the compass error for the compass bearing steered and apply that to all bearing taken whilst on that course. So example, we are steering 076 degree. uh, the deviation from the deviation from the deviation card, for 076 is 3 degree west, and the variation from the chart is 11 degree east. So the compass error com- combined variation and deviation is, therefore, 8 degree east. Since we are converting compass bearing to true, we add east. So therefore, wheel steering is 076 degree. Then add 8 degree to any compass bearing to convert it true. So the simple layout for applying variation and deviation. So first is changing from compass to true. So compass, so we have the compass course of 215 degree, and the deviation of 6 degree west. In this case, between it is between 210 and 220. So our magnetic course is 209 degree, and uh, add is add if is it east. So in our case, we have west, so we will subtract it. So in the variation, we have 11 degree east. It is found in the chart, and we have the true course of 2 220 degree true. So number 2 is changing. It is number 2 is changing from true to compass. So true course our true course is 220 degree true, and our variation is 11 degree east. It is from the chart. And also our magnetic course is 209, because we subtract the true course in the variation. So we will come up with 209 of magnetic course. Then our deviation is 5 degree west. It is from the table for 2210. And then our compass course is 214.5 1.5 degree since we add the magnetic course and the deviation. So for most practical purposes, this compass course is sufficiently accurate, but to be strictly correct, we should re-enter the deviation table with a compass course of 214 degree rather than the magnetic course of 209 degree. In this case, deviation should be 6 degree west and the total working as follows. So the difference is rarely like to be great, but be aware a deviation card which indicates rapid changes in the deviation. So when working with bearings, the same layout is followed, but remember that the deviation table is entered with ship's head, not bearing. So so that would be all for our report on the topic of application of compass error. Thank you and have a good day.